Okay, so let me share my screen and then we can just start discussion over VXLAN, right? So yeah, guys. So uh, let's start with what is VXLAN, right? So anyone can tell what is VXLAN? Let's keep it interactive and discussion, at least this VXLAN one, and then we can move to EVPN next time. So yeah, what is VXLAN? Why we need, what problem VXLAN is solving? Anyone?
Scalability issues in the VLAN. We only have like 4096 VLANs. With the VXLAN, we can have 2 to the power 24. Uh,
Right. Yeah, that's one is scalability, right? So anything else? What is the common problem with our authentic, data center or any campus uh, design, and
Uh,
how we can, improve on that by using VXLAN?
no blocking ports means all the links are active.
Yes. So basically, in traditional, we use STP, right, to avoid loop. And as we all know, when we use STP, we won't be able to utilize all the links at full capacity. Definitely, we can use, different variants of STP to improve on, but still, we won't be able to utilize at full bandwidth, right? Our infrastructure. So that is one. Anything else related to STP?
uh, there's no layer 2, right? So any issues that comes up with the layer 2 will not be seen.
Yes, that is all the most important point, right? Because we know we have been working with STP, right, since long, and we have seen a lot of issues related to STP. And we know that even a small issue with STP can cause a loop in full design or topology, and it can bring down, you know, a whole site, correct? So that is one another important top point, that STP, it's issues related to STP which we will not see with VXLAN, right? Okay, any other top point you want to add? Anyone wants to add? Okay, so let's move on. So yeah, basically VXLAN is nothing but, because now we are not going to use STP, right? Basically between leaf and spine, we will have layer 3 in interface, right? Layer 3, not layer 2. So obviously we won't be able to extend the STP. And now if we want to communicate between two devices who are connected through L3 network, right, we need some tunneling protocol so that we can communicate between these two, right? And that's where VXLAN come into place. So basically it's nothing but extend layer 2 over layer 3 infrastructure, right? So it basically it carries the virtual layer 2 network over scalable layer 3, right? That which solves the vMotion across subnets. So anyone has any uh, everybody knows what is vMotion? Or if you want, we can discuss.
Yeah.
Yeah,
Okay.
so do we want to discuss what is vMotion, or are you guys familiar with that?
Yeah, we
Okay. Okay, yeah, let's just quickly. So basically, let's say consider this is the our topology, right? So this is switch 1, switch 2, and this is our L3 network, right? L3. And you can consider this as a ISP network, right? ISP. And these are two DCs connected with each other through ISP. So this is, let's say, DC1 and this is DC2, right? Now, if we want to move this H1 host, which is, this particular VM, which is on ESXi host here, but because of resource issue on this particular ESXi host, we want to move it to another site, right? Another location, another DC2, where we have enough resources. So basically we want to move this from one ESXi host to another ESXi host, this particular VM, right? And to do this, what basically we want to achieve is, we don't want to change this IP address. So we want to make sure that this IP address remains the same, and as well as gateway also remains the same. So let's say this is the gateway 10.1.1.255, right? It should remain same. So basically I don't want to, change anything. Just a minute. Right? I want to make sure, because it's not only one VM, there will be hundreds of VMs which will be moving across data centers, right? And it's not possible every time to change the IP address or gateway of that particular VM, right? So basically what we want is, let's say this is VLAN 10, we want to extend that VLAN 10 here. We want to utilize same gateway, right, at another DC, and basically we want to make sure that the communication between this VLAN 10 host here and VLAN 10 host here also should be possible over L3 infrastructure, right? So that's where VXLAN come into place, where we will encapsulate the packet at VTAP, loopback address, by using loopback address, and send out that packet across the L3 network, right? Any question on this?
No. Oh,
Okay. Yeah. So
Hey, Vishal.
yeah, yeah.
So this is a question has always been having at the back of my mind, just with respect to what I don't know who said it earlier, concerning the advantage of VXLAN having the more than the 4096 VLANs that we traditionally did have, right? So
Yes.
how normally does this advantage come in? Because at the end of the day, you would still have to create VLAN to VNI mappings. So you can only create 4096 VLANs to map to another VNI. As much as you could have millions of VNIs, but you still have 4096 VLANs, right?
Yeah.
So how does that advantage come into play?
Okay. Yeah, that's a good question. Anybody wants to answer before I give my point of view?
I think it comes in handy with the combination. Maybe VNI 100 is mapped to VLAN 100 on suppose one VTAP, but maybe on another VTAP, VLAN 200 is mapped to VNI 100. So basically, yeah, bridging of the VLAN leaking. It's the combinations which can be extended.
Okay, so like the traffic when it leaves one VTAP is going to be under VLAN 100, VNI is going to be 100, which is common on both. But when it gets to the other side, it's going to be placed in VLAN 200.
Yeah.
Okay, but normally we keep this similar in terms of we say this should be the same. The mapping should be the same, or
Yeah, it should be the same if you want to move the traffic across VLAN 100 to 100.
Okay.
I think I might be able to maybe try and answer.
Yeah.
Victor, so imagine you have like one VXLAN fabric, switch 1, switch 2, the ISP, but then switch 1 and switch 2 can connect to like different customers. So you can have like customer A and customer B. So like, let's just say customer A host 1.
Yeah.
So like on both sides, you'd have host 1 for customer A and host 1 for customer B. And let's say they use the same VLAN, right? So both customers use the same VLAN 10, for example.
Yeah.
But you map customer A to one VNI, VLAN 10, for example, VNI 1010. But then for customer B, you map VLAN 10 to another VNI, so you don't mix up the two VLANs. Like the end customers still are limited to the 4,000 VLANs or so, but the VXLAN fabric you're limited to more like a few million or whatever the number is.
Mm.
Yeah, that is one of the another use case. Obviously, on seam switch you can't use 10 to 1010 and again 10 for, let's say, customer B is also connected here, right, with VLAN 10 to 1020. But as Kamil mentioned, on another switch at least you can differentiate the customers, right? VLAN 10 customer as 1010, which is customer A, and we on another, let's say, another leaf device, you have customer B connected with VLAN 10. Then for that you can differentiate with 1020, as Kamil mentioned, right? So that way basically you can differentiate, and at the other end also you can choose which VLAN or which traffic you want to take, whether customer A traffic or B customer traffic, right?
Mm. Okay. Mm.
Okay.
Making sense, yeah.
Yeah. Anyone else want to add?
Michelle, just one thing.
Yeah.
You know how we have like customer A VLAN 10 and customer B VLAN 10 connecting to switch 1?
Mm-hmm.
Okay, I guess, can we make one port in one? Oh no, because the
Yeah,
VRF is
but
layer 3 concept, so
VLAN
you
to
can't do it.
VNI
Okay.
is going to same, right? So let's say VLAN 10, we configure VNI, 1010, right? We can't give another VNI 1020 for same VLAN, right? On same switch.
Yeah, okay, that makes sense.
Right.
Yeah.
Yeah, but definitely see on another switch, right, where customer B VLAN 10 is connected, you definitely can configure 1020, right? So that way you are differentiating basically.
Yep.
Okay, any other points? Yeah, so I just want to add one more point is, when we come to L3 VPN or, you must have heard about dynamic VLANs, right? Or we also assign WRF to VNI mapping, right? When it comes to L3 EVPN, right? So in that also we need more VNIs, right? Because let's say you have 100 WRF. So for each 100 WRF, we need to assign VNI, different VNIs, right? So that is another, basically you can say, use case where we need more VNI compared to actual 4096, right? Because it's our usage of VNI is not restricted to only VLANs. It is also we are also using for identification of WRF, especially in symmetric IRB, right? In EVPN, we will discuss this, but yeah, this is one more use case which, where we need more VNIs.
Okay, thanks.
Okay, anyone wants to add anything on this? But yeah, this is good. I think this is how we wanted to do. Basically, let's discuss, right? That way it will be good for, okay. So yeah, so VXLAN. So I think everybody now is clear, right? Why we need VXLAN and what problem VXLAN is solving. So one is, as Akshit and other folks mentioned, right, that STP, loop free, and limitation. This also we have discussed, right? Why it is limited. VLANs are limited to 4094, while VXLAN we will have 16 million logical networks. Increase in multi-tenant environment accelerate need for larger VLAN limits, right? And vMotion and that all is possible by using VXLAN, right? Okay, so moving to next. I believe everyone knows about different types of tunnels, right? IPsec, GRE, MPLS tunnel, and VXLAN tunnel. So we'll not go much in depth. on this. Now let's how we are solving this problem, right? So we decided that we can have VXLAN tunnel, right? So this is our two host and this is to switch, and it is connected through L3 interface. How can we? So here basically, we will create a tunnel, right? VXLAN tunnel. So what are the information we are adding? So this is our normal packet, right? So source IP, and this is the destination IP, right? Source MAC and destination MAC. So this is our normal packet. Now it comes here and we have to encapsulate over the VXLAN, right? So what are the information we need to add?
Source IP, destination IP.
Yes, source IP, destination IP, right? So this
The
is
tunnel,
loopback IP
yeah.
here, right? And here this is the loopback IP, right? So basically to tunnel the packet, we will add source IP and destination IP. What else?
The layer 2 headers, source MAC and destination
Yes,
MAC.
source MAC. Yeah, top of that source MAC and destination MAC, right? Okay.
Yeah.
Is this sufficient?
You would need the VXLAN identifier as well, VNI.
Okay. Okay. Yeah. So basically, you see, this is basically this information is enough to send packet, right? Whatever we have received here, send it to this VTAP or switch, right? So that is enough. But when this is, let's say, VLAN 100 packet, right? Now, how would you know that this packet, whatever I have received, when I decapsulate this packet, I remove this header, how do I know that in which VLAN I have to process this packet or forward this packet, right? Because there is no VLAN information which was here available, right? This VLAN information, at least from this port access port, we were knowing that this traffic is for VLAN 100, belongs to VLAN 100. But when we reach here and we decapsulate, remove this outer header, we don't know which VLAN this packet belongs to, right? So that's why we need to add extra header, right? Which is nothing but VLAN to VNI mapping, basically VNI information, right? So that here for VLAN 100, let's say we have VNI 100. So we will also add VNI 100 here, right? So that here when we decapsulate the packet, we know that it is this packet belongs to VNI 100, which further points to VLAN to VNI mapping, which is VLAN 100 points to VNI 100. So we have to, process this packet into VLAN 100, correct? So that is, so yeah. So this is how we will add this VLAN to VNI mapping, correct? Anything else, or this is sufficient to make this work between host 1 to host, this 2 ping?
The UDP header.
UDP header. Okay.
Yeah.
Why we need UDP header?
Because
what is the purpose of it?
We need to tell the switch to that it should be encapsulated, like to identify that this is a VXLAN tunnel.
Okay. So where exactly we need this UDP? Basically, which switch has to identify?
The switch 2.
Okay. So basically, as you know, you pointed out, this is L3 interface, right? And it's not about that this has only this connection. So actual, if we see, then it can be like this, right? This is ISP in between, and it can be like this, right? And there are possibility that it's not that all the traffic which is landing on this leaf, this is leaf, right? All the traffic landing on this will be VXLAN encapsulated traffic, right? There is possible that you have some you are accessing some, say, google.com from this host, and that traffic will be naked, means it will not be VXLAN encapsulated. However, that also will land on the same interface, right? On this your switch 2. So basically this interface on switch 2 will get different type of traffic, which is one is naked traffic, right? Without VXLAN encapsulation. And another is VXLAN encapsulated traffic, which is coming from this host, right? So how the switch will understand that I have to decapsulate this packet because it's VXLAN encapsulated for this VXLAN packet. And if it is a naked traffic, it will understand that I don't have to decapsulate because it's a naked traffic, right? So for that reason, we need destination port, right? UDP. So basically we will add UDP header information. So here we will also add UDP header where we will have UDP destination port, which it is fixed for VXLAN default. So basically default for Arista, which is 4789 UDP destination port, right? You can change this, but you have to make sure you change on every leaf devices. So now when you encapsulate this packet here, you will also encapsulate with 4789 UDP destination port. So when this traffic comes here on this switch 2, it will check for this UDP destination port header, VXLAN header. And if it finds that it is 4789, that means this is VXLAN encapsulated packet, and it will decide that I have to decapsulate the packet, right? And when this naked packet comes in, it will not have UDP destination port as 4789. So it will be treated normally. Okay. Make sense? Any question?
Oh, it's good.
Okay. 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 So yeah, so that's why we have UDP destination port, right? 4789, so that this site will know that this is a encapsulated packet. Anything else we are missing here, or this is complete?
It should be enough.
Enough?
Yeah.
Okay. But one thing is not here, right? Is what? UDP source port, right? Because when you are adding UDP header, there should be destination port and source port, right? And this is, if everyone knows, this is not fixed, right? It is random. Is it correct?
Yes.
Yeah.
Okay. Anyone knows why? What is the reason for this?
In case we have a multiple links between a spine to what to say leaf, to load balance the traffic perfectly, the source port is required.
Yeah, because see, whatever traffic comes in, right? Or even let's consider this is spine, right? And you have multiple leaf links to leaf devices, right? So basically, see, your outer header is, so basically when this packet lands to spine device, right? What it will check for hashing ACMP, because to go send packet to switch 2, it has multiple paths, right? 3 paths. So how he will decide that which link I have to use by using hashing, right? Or load balancing, ECMP. So for that, it checks the outer, all the, this outer destination, outer source IP, UDP port. If everything is same, then it will end up choosing only one link, right? Out of 3 or 4 or whatever options it has, right? That's why we keep this source port, UDP source port random. So that will be differentiate and hash on different links, right? Because for each flow, this UDP source port, at least that only field which will be different. And on what basis we choose this UDP source port? That we choose based on the original packet source MAC and source IP. So combination of this, based on this, we generate a UDP source port, right? Random 1, 4, 2, 3, anything based on this field. And for each flow, this will be different. And because here this UDP source port is different for each flow, we will be able to utilize all the links, right? Through ECMP or hashing. So that's the purpose of UDP source port, which is random and not fixed. Any question or any? Okay, so I think now we are done with our header part. So this is the header, right? So this is our VXLAN UDP source port and destination port. This is VXLAN header where we have VNI information, VLAN to VNI mapping. This is the inner header, and then this is the outer header, outer IP address and outer Ethernet header. Okay. So any question on this header part? Okay. Guys, Aniket, Sachin, feel free to add if I have, missed anything. Till now.
I think Samsung Sagar. Sorry, no, Vishal. Everything is covered, I think.
Yeah.
Okay.
Yeah, Vishal. Looks clear.
Okay, fine. So we are not going to discuss this, because I think most of us know this, right? So this terminology. And yeah, let's now discuss the packet flow, right? Which is most important. So, okay, let's take this topology, right? And let's discuss the packet flow, VXLAN packet flow between H1 to H2. H1 is 100.1.1/24. H2 is 200.111/24. Gateway is 100.1.100 and 200.1.100, which is configured over leaf devices, right? VTAP. This is the gateway, and this is the gateway for both the VLANs. So both SVI is present on both the VTAPs. Okay. And yeah, so we have just set up this, right? This is the spine, this is L3 link. Okay. And we have just set up this topology, and now we want to ping from H1 to H2, right? Anyone will tell what will be the, how is the packet flow? Who wants to start?
I can start.
Yeah.
So H1 will send a ARP request
Okay.
for its gateway.
Mhm.
Source MAC will be MAC1, DMAC FFF.
Okay. So see, let me. So this is the ARP header. Okay, this 4,
Mhm.
and this is Ethernet header, top of it, right?
Mhm.
Yeah. So here, okay, FFFF, right? Okay, what is
Yes.
this now? ARP header. Let's talk about ARP header. Sender MAC.
Center MAC should be 1.
Mm-hmm.
Destination MAC should be 00.
Mm-hmm.
Source IP should be 100.111. Destination IP 00. Oh, sorry. Destination IP should be 100.1.1.100.
Okay, perfect. So now we have sent this ARP request, right? It reaches to VTAP1. What VTAP1 will do?
It will update its MAC table. So
Mm-hmm.
it will be VLAN would be 100.
Mm-hmm.
MAC would be 1.
Mm-hmm. Let's consider
Interface.
ET1, right? Here it's we
Okay.
have not, yeah, ET1. Okay.
Okay.
What else? Now what else?
So now this should reply to H1, and H1 will have.
Okay. So when it receives the ARP request, whether will it update anything else, any other table?
ARP. It's ARP table.
Okay. Yeah. So
100.1.1.
okay.
MAC
So
1. 100.1.1. MAC 1. ET1.
Okay. Okay, so it has updated MAC and ARP table and it will reply back, right? Right?
Yeah. Yeah.
And as this reply comes back, what will happen?
So H1 will update its ARP table. IP would be 100.1.1.100.
Mhm.
MAC would be A interface, whatever.
ETV1, let's keep it. Okay, perfect. So now H1 learned the ARP, right, for the gateway. Now what will happen?
Now it will send an ICMP
ICMP.
request.
Yeah. So ICMP, right? ICMP request. Yeah. What are the fields? Let's remove this too, right? Source MAC.
Source MAC 1,
Mhm.
DMAC A,
Mhm.
source IP 1, and this is okay. Okay.
DIP
200.
200.
100.
Okay. Now who else will go forward? Come on, guys. I will help you. Come on. Just try it out.
I can probably go. So
Yeah.
so host 1 sending the ICMP request up to VTEP 1.
Yes.
So VTEP 1 gets it and then encapsulates it into a VXLAN packet. So the lower yellow fields would be probably the same.
Mhm.
It's the encapsulated packet.
Okay. Mhm.
The source MAC and the destination MAC.
Okay. So let's put it here, right? Okay. So now, okay. So first of all, this packet has received here, right, on VTEP 1, right?
Mhm.
Right. What will it do? So first it will check the destination MAC, right?
Oh, if it has a entry, yep.
Its own MAC, right? And destination IP is
It is not itself, yeah.
yeah. It's basically it is its own connected network, right?
Mhm.
SVI 200 is also configured here. So first of all, it will check the destination MAC, its own MAC. That means I have to process or I have to route this packet, right? And then it checks the destination IP and it checks the routing table, right? Because now it has to send this packet to this IP address 200.1.1.1. So it will check the routing table where it will find that destination subnet, right? IP is directly connected with VLAN 200, right?
Mhm.
So
Yep.
now what it will do? Now it has to send packet to 200.1.1.1, right? What will it check?
I guess because it's not in the same subnet.
Mhm.
So it checks the route. Mm,
Yeah, you are right. It will check the routing table, right? So basically,
Mhm.
and it will understand that I have to send packet to this VLAN 200. So basically here it will route the packet from VLAN 100 to 200, right?
Yep.
Now it will check the destination IP is 200.1.1.1, right? And it should know the ARP for MAC for this IP, right?
Mhm.
So it will check the ARP table. Whether I have ARP for 200.1.1.1 or not, learn, right? On this.
Yep.
And if it is not there, then what should it do?
I think it'll send an up request over the VXLAN fabric to H2 to try to
Yes, that's
resolve it.
right. Perfect. Yes. So now it has to send out the ARP request, right? Now let's fill in this. So what should be the source MAC of ARP request?
I think it'll come from the SVI, so probably Mac A.
Yeah, that's right. DMAC.
DMAC.
It's ARP request, so it's all
Should be
I think
FFS.
it'll be
FFF.
Mac B. Okay.
Because it does not know, right? See, it has to send out
Oh,
ARP
right.
request. Yeah.
It'll even go to all the other VTEPs if there were other
Yes,
ones,
yes.
right?
Yeah. Okay, what will be the source MAC? This is the Ethernet header, right? This is Ethernet header, and this is our ARP request, ARP header. So it's again A, right? DMAC is 0000 because it doesn't know what is the destination MAC for this IP, right? Sender IP is
100.200.
Yeah, this is the IP because now it has changed it to VLAN 200, right? It has routed from VLAN 100 to 200, and in VLAN 200 it is sending out R for this subnet, right? This IP address, right? So source IP, sender IP will be 200.1.100 gateway IP address, and destination IP is for which it wants to resolve the MAC, right? Which is this one. Is it clear and make sense? Any question on this?
Yeah, it's clear. I actually was blank for a second. I thought it just encapsulates the ARP and floods it, but I guess it comes from the SVI. I guess because this is layer 3. If it was layer 2, then maybe it would do that.
Yeah, that's right. Yeah. Okay. So now we know, right, that, okay, so this is our header. Now we have to encapsulate this, right, into VXLAN header because we want to send it over L3. So what should be the VNI?
Uh, 200.
Yeah, let's consider VLAN 100 as 100 VNI and 200 VNI, right? Same. So it's a 200 because we are sending traffic on VLAN 200, right? Okay, what is the UDP source port? It will be generated randomly based on this header information, right? Destination port will be
4789.
4789. Okay, what is the source IP? What is the source IP?
I think loopback 1.
Yeah. And what will be the destination IP?
2.2.2.
Okay, so how do we know, right, that which VTAP? Let's say this is 1, but we also have another VTAP 3. Okay, VTAP 3 with IP address loopback 3.3.3.3, right? And there are hosts in same VLAN 100 here as well. So how we will know that, I have to send this packet only to this VLAN, this VTAP 2222 and not 333, or based on what we decide that where we have to send this packet, which destination IP?
Based on the flood list that we define.
Yes, so basically what we do in configuration is we define that VLAN 100, right? VTAP flood, VTAP 2.2.2.2 and 3.3.3.3 for this topology, right? So basically, when you have to send out broadcast traffic, when you want to send out bump traffic, basically not broadcast, right? Bump traffic, that is broadcast, unknown unicast or multicast traffic, right? Over VXLAN encapsulated, you don't know, right, under which VTAP this particular host resides, which you want to go to, right? Communicate to. And that's why we need HER, hidden replication, that will give us all the VTAPs which are part of VLAN 100, right? Which is extended for VLAN 100. So basically, whenever VTAP has to send out bump traffic, it will refer this command configuration, where it will understand that for VLAN 100, I have, these are the other VTAPs who are part of that VLAN 100 or extended, right? VLAN 100 extended to. And based on that, it will create multiple copies for each this VTAPs. So first one copy it will send ARP request to 2222 and another copy it will send for 3333, right? So it will send two copies, one for 2222 and another is for 3333. Does that make sense? So basically now your ARP request will go, one ARP request will go here, another ARP request will go here. Is it clear?
Yes, yeah.
Any question on this? Anyone has any question or doubt on this?
Vishal?
Yeah.
Yeah, I had a quick doubt. So if when we go back to when H1 was sending an ARP request to the gateway, right? So
Yeah.
in that case, since it sees that the destination IP is mine, and since the MAC is also mine, it won't be replicating the packets and sending it to the other VTEPs, right? In that case, because it
Yeah,
sees.
because it's for gateway IP address.
Okay, okay. Yeah.
So yeah, basically it also, in that case also it sends it to the other VTAPs and other VTAPs will respond back if they also belongs to the same gateway IP. So that, yeah, basically okay. So see, basically when this ARP request comes here, right?
Yeah.
It will, what table it will refer? It will refer the VLAN table, right? And VLAN table, it will see that, so for show VLAN, right? Show VLAN 100, if we do VLAN 100, what
Yeah.
it shows as the VLAN 100 and what are the ports, right? For which belongs to this VLAN. So one is this ET1. There are other ports as well. So let's say ET1, ET2, ET3. And because we have extended VLAN to VNI on this VXLAN, right? It also shows VX1.
Vishal, I think I lost you. Was it only me or
Yeah, okay.
maybe
So
just repeat here?
okay, so let me start again. So when we check show VLAN 100, right? VLAN 100, there are many ports which belongs to VLAN 100, right? 1, 2, 3. And because we have extended this VLAN over VXLAN, VLAN 100, it will also include VX1 interface. So basically, when any bump traffic or broadcast or ARP request comes on this switch, it will refer this VLAN table to understand, hey, what are the ports which belongs to this VLAN where I have to forward or flood this traffic, right? So based on that, it will flood the traffic. Now, because this is for gateway, it will obviously this will reply back, but this
Correct.
will also be flooded to other VTAPs, ARP requests.
Understood. Understood. And if that they are not the one destined, then they'll just drop the packets. Otherwise, they'll also send
Yes.
a reply in that case.
Yes. Otherwise, they will also respond back with ARP reply.
Correct. Correct. Okay.
Okay.
Got it, Vishal. Yeah.
Yeah. Yeah. So we will discuss more about this issue in next 5-10 minutes. But yeah. So any other questions?
I have one.
Mm-hmm.
When host one sends the ARP request to VTEP one,
Mm-hmm.
VTEP one resolves the ARP for host one. Like it doesn't have to send an ARP request down to host one.
Okay. So when H1 sends the ARP request, right, to VTEP1, it will update its ARP
Yeah,
table.
I think Vishal, your internet is slightly
Yeah.
choppy.
Or is it?
Now it's fine, I think.
Now it is fine,
Okay.
but in
Yeah,
between.
when the ping is
Okay.
happening.
I don't know what. Okay. So yeah. So when H1 sends out ARP request, right, based on that ARP header, it will update its own ARP table, right? VTEP1.
Okay.
And because the ARP request right here, let me. Okay. So So this is the app request, right? And here it's 100 to 54, right? 100, sorry, 100. Gateway is 100. Okay. So this is the ARP request, right? When it receives here, it checks that destination MAC is okay. It is all F, right? That is the I have to flood this request, but it also checks that destination IP is my IP. I belong to my IP is this, right? So basically it will reply back. It will send the ARP reply to H1. Okay. But because this VLAN is also extended to another VTAPs, right? It has VX1 interface as well. It will also flood this app request to other VTAPs. So it will respond back because it has IP address, but it will also flood it to other VTAPs so that if because this is flood bump traffic. Destination MAC is FFFF and VX1 is part of that VLAN.
Okay.
Okay. Yeah. So okay, so now let's come to right. VTAP2 basically receives the packet, right? What will happen? This ARP request, right? This ARP request is received here at VTAP2 because now we are sending it only to 222, right? 333 is not there. What will happen? What VTAP2 will do?
It will de-encapsulate it.
Yeah. So first of all, it will check the destination IP, which is 2222. It belongs to its own, right? And also destination MAC, which will also belongs to its own MAC, right? So it will decapsulate the packet. Then, okay, on what basis it will decide how to decapsulate the packet?
UDP destination port.
UDP destination port. So based on that, it will understand that this is VXLAN encapsulated packet. It will decapsulate this. What else? Next, what is next?
Once it de-encapsulates, it will check the destination MAC.
It will check the VLAN to VNI mapping, and then it decide that this frame is belongs to VLAN 200. And then it's a ARP request. So after that, it will check the VLAN table and then flood to all the respective ports.
Yes. So basically, after decapsulation, it checks the VNI, right? 200, and VNI 200 is mapped to VLAN 200. So it will understand that I have to treat or process this packet into VLAN 200 or forward into VLAN 200, right? Next, it checks the destination MAC. What is that? FFFF. So basically, it understands that, hey, I have to flood this traffic, right? Send, broadcast this traffic. Now, on which are the ports it has to forward this traffic? It will refer the show VLAN table, right? Show VLAN for 200. And all the interfaces, this is, let's say, T1, there are other ports which are part of VLAN 200, 1, 2, 3. It will flood that traffic to all the ports, right? It will not forward again to VX1. Here, VX1 will also be there, but it will not forward it because from VX1 only it has received that, right? So yeah, it will flood to all the ports. Now what next?
So on VTAP2, are we also learning the MAC for VTAP1 SVI 200 and?
Yes, so we will update these tables, right? Yeah. Can you tell me what are the information we'll update here?
So that's for VLAN 200. And the MAC is A.
Yeah, MAC is A and interface?
Should be is it VX1?
VX1, yeah. What about, yeah.
There we learned that we have the So we'll also learn the, okay, so we have the from the app request, we have that which one is this? Yeah, from the packet we also learned that or rather the H1 Mark A. Oh wait, no, not. Do we learn that actually? I think we learned that in the VXLAN address table, right?
Yeah. So yeah, your VXLAN address table, what we will learn. So it's VLAN.
VLAN. Oh no, actually, yeah. So yeah, VLAN to 200.
Yes, you can refer this, right? So VLAN 200, right? What is the MAC, source MAC?
MAC A.
A, yeah. And from which VTAP you have received?
Is 1. Where is it? Is it 1.1? Yeah.
Yeah, this source IP, right? Outer source IP. Yeah. So basically you are updating your MAC table and VXLAN address table, right?
Yeah.
And you might update our table if, so generally this is same, right? Basically on all VTAP gateway IP address, SVI IP address is same. That's what we configure. Although in this scenario, we have taken it different because this was starting, we have not explained them, VAR concept or IP address virtual concept. So we have taken it different, but otherwise it is same, right? Across every VTAPs. In that case, because it's own, it has own IP address, it will not update our table, right? Okay. So basically now you have updated this based on the packet you have received, right? And you have forwarded that ARP packet to ARP request to H2, right?
Yeah.
What H2 will do?
So H2 will see that the app request is for itself. So, and then it should generate an app reply.
Yeah.
So send an app reply now.
Yeah, and it will also update its own table, right? For gateway, correct? So gateway is A and interface is ET1. Let's keep it this ET1, right?
Yeah.
Okay, so now it will reply back, right? ARP reply. So let's send out ARP reply. Okay, we already have here, but yeah, let's take this. Yeah, what will be the source MAC? Reply?
So 2. So 2, yeah.
DMAC?
The MAC is 1.
Okay, why 1?
No, sorry. It's this guy. It's the reply should go to. Wait, this is a request that came from the SVI, right?
Yes, from VTAP 1, right?
Yeah.
So you can refer this. See, this is the request, right?
Yeah. So that's A.
A, yeah.
Yeah, so that's the same, right?
2, right? Source MAC is 2 and DMAC is again A.
Yeah.
What is the source IP? Or sender IP?
Yeah, the 200.1.1, 100, yeah.
This is 1, right? 111, 200,
Oh, it's 1. Oh, yeah, gateway is 100, yeah.
Yeah,
so,
and this destination IP is 100, 200, 11, right?
Yeah.
Okay, so you received this ARP reply here. Now what? VTAP 2.
So we'll check the DESMAC and see it's supposed to go to A.
Okay.
Then we'll check our MAC address table, see that MAC is launched via VX1.
Correct.
So check the flood list, check the VXLAN address table and see that that MAC is launched behind VTAP 1.1.1. So encapsulate, create a packet and encapsulate the app reply into a packet that goes towards 1.1.
Yes. So basically we will add this right here. right?
Yeah.
So this is our inner header, right? VNI will be 200, correct? And UDP destination port 4789 and destination IP, outer destination IP is
1.1.
1.1.1.1 because this A is behind VTEP 1111, right?
Yeah.
And source IP will be, outer source IP will be 2.2.2.2.
Yep.
Right? And then this is the source MAC, outer source MAC will be B and outer destination MAC will be C. This one, right? Immediate next stop.
Yep.
Okay. So now this packet comes here at VTEP 1. What VTEP 1 will do?
Yeah, continue. Someone else will take it up.
Yeah, sorry.
I'm saying maybe someone else will take up, or do I continue?
Yeah, maybe anyone. Yeah, other can.
I can probably go. So when VTEP1 gets the packet, I guess it looks at the destination IPs for itself. Yes. It also sees that the UDP ports 4789, so it's known to VXLAN and to decapsulate it.
Yeah.
The VNI is 200, so it'll put that packet into the mapped VLAN. So it goes into VLAN. Oh, sorry, it'd have to.
Yeah, basically treat this packet as a VLAN 200, right? Process it or.
And then route it after, I guess.
Yeah. So what is the destination MAC? So based on this destination MAC, it will decide, right, whether I have to process this packet or consume this packet, right? Or I have to send it to other device, right? Route the packet, correct?
Yeah.
So what is the destination MAC? Its own MAC?
Yeah, I think the switch MAC. Yep. Oh, sorry, the SVI's MAC.
Yes. So basically, it has to process this packet, right? It's for CPU.
Yeah. Yep.
Right. Okay. So now what is the inside packet?
Also, I think it's source MAC was.
Yeah. So this is our reply packet, right? So it will, basically consume or process this ARP reply, right? Because it's for its own MAC address, right? So based on the information ARP reply packet, it will update the tables, right?
Yeah. Yeah.
So what is the source MAC? 2. So basically it will update this MAC table first. So it belongs to which VLAN? 200, right? So it will update that VLAN 200 MAC 2 belongs to from which VX interface?
VXLAN.
VX1.
Or
right?
VX1. Yeah.
Yeah. Now as it has updated the MAC table, it will also update the VXLAN address table, right?
So yeah, it'd be the VNI is 200, so the VLAN would be 200. The MAC would be MAC 2 or host 2, and then VTEP would be coming from VTEP 2, so 2.2.2.2.2.
Yes, so you will get all this information from this, right? So VTEP is 2222, right? VLAN is 200 and source MAC is 2. So it will update here, right?
Yeah.
Anything else it will update. This is ARP reply.
We learned the app for H2, right?
Yeah, actually, because we have sent ARP request for this H2, right? So when we get the response back, ARP reply, we will update this, right? Right. So this is now 2 and this is over VX1. Okay. Make sense?
Yeah. Yeah.
Okay. So now we got so basically what we did, right? From start, H1 sends out the ARP request. It gets the reply back, ARP reply from the gateway, right? it updates its ARP table and it sends out the ICMP packet. So here it is ICMP packet, right? ICMP request. And this is the source MAC is 1. This is A. 200 is this, no, source IP is 100, right? And this is 200, right? So this is the ICMP packet. So now ICMP request comes here. VTAP21 will check the destination IP 200.111, which is directly connected to VLAN 200. So it will route the packet from VLAN 100 to 200 internally. And then it checks for the ARP for the destination IP, right? 200.111, which we have already now resolved. So to send the 200.111, we have to send packet to MAC2, right? So now again it will hand over VX1 interface. So MAC2, to send packet to MAC2, it has to send it to 2222. So now it will encapsulate this packet, right? ICMP request packet here. So this is our ICMP request packet. We have to encapsulate because to send MAC2, it is behind VTAP 2222, right? So basically the destination VTAP is 2222, right? VNI is 200 because it's VLAN 200. Source MAC, this is A, destination MAC is 2, right? This is the source MAC, this is the destination MAC. Make sense?
Yep.
Yes, yeah.
Okay, and then this packet comes to VTAP2. Again, it will remove the outer headers. Destination IP222 it belongs to its own, so it will decapsulate the packet because it's VXLAN packet. VNI 200, which is mapped to VLAN 200, so it will understand that I have to send this packet, forward this packet to VLAN 200. What is the destination MAC 2? Destination MAC 2 is learned. Okay, we did not update here the MAC table, right? When our reply came. So let's do that quickly. 200 MAC
2.
2, and let's keep it TT1, right? Okay, so basically, yeah, it will check the destination MAC 2, right? Which came, which is on ET1, so it will forward that traffic here out on this interface only. And then ICMP reply reverse. Okay. Any question so far? I think we need to stop here today. Maybe we will need one more session to discuss on VXLAN. But yeah, any question for so far what we have discussed?
No, Vishal, it's clear.
Okay. Anybody?
Yeah, clear.
Okay. Anyone else has any question?
No.
Okay, perfect. In case you guys, anyone has still has any problem, don't worry, feel free to reach out to any of us, right? And we will be happy to discuss this, because this is a main basic concept even for VXLAN, right? So without this, we can't go to VPN, right? So just feel free to ping any of us, right? And we definitely would be happy to discuss this with any of you. Okay. So next we'll have, I'll send out invite for Tuesday. Basically, we'll keep Tuesday and Thursday, right? So next Tuesday, we'll again discuss VXLAN. We'll cover the VXLAN few part of VXLAN. And after that, VXLAN routing we have already discussed. So after that, yeah, we'll discuss direct routing and other concept of VXLAN. And I believe from next Thursday, we should be able to start EVPN. Okay. And I'll also put this recording. So yeah, if you want to go through this recording, feel free to.